Tonight's Dr. Dave Robinson is a distinguished professor of geography at Rutgers University and a New Jersey state climatologist. As state climatologist, he works with a wide array of stakeholders who require climatological information and expertise to solve problems. He also directs the Rutgers New Jersey Weather Network, a constellation of 69 automated weather stations, and co-leads the New Jersey chapter of the community collaborative Rain, Hail, and Snow Network. Globally, Dave conducts research on the role of snow cover in the climate system and as an indicator of climate change. Dave is a past president of the American Association of State Climatologists and is a fellow of the American Meteorological Society. Okay, so before we get started, just to let you know, if anyone has questions that come up during Dave's talk, please put them in the chat. Dr. Robinson, we're so excited for your talk, and I'll hand it over to you. Thank you so much.
Excuse me, I'm sorry to interrupt. Please put them in the Q&A, not in the chat.
Oh, sorry about that, Elaine.
Yeah, there's a separate button for Q&A at the bottom of your screen. Sorry, Jen.
Yeah, thank you.
Okay. Thank you, Pauline, for the lovely introduction. It is a pleasure to be here with you virtually this evening. There are benefits, I know, of virtual talks and such, but I do miss face-to-face contact, although it is miserable getting up to Bergen County on any weekday night or Passaic County. So thanks for going virtual with this. I should add, I should preface it that I am a native of Bergen County. Spent my formative years there and still go up and visit my sister at the family home in Tenafly. And I actually owned a home while still in grad school at Columbia in Westwood. So that's home. But I've lived in Somerset County since coming to Rutgers in 1988 as an assistant professor and gone through the ranks and such. And in 1991, I was appointed state climatologist by the dean of the Agricultural Experiment Station. It's also the dean of Cook College, which these days is known as the School of Environmental and Biological Sciences at Rutgers. Thus, I have a split line between SEBS and the geography program, which is part of the School of Arts and Sciences at Rutgers. So I get to know all the deans and have had a wonderful, long-lasting career at Rutgers. And I tell many people, if I had known there was such a thing as a state climatologist when I was growing up, that's what I would have wanted to be when I grew up, in a sense, because like many in the meteorologic, climatologic realm, we trace our love of this subject back to childhood. My first week of kindergarten, Hurricane Donna hit, and I remember it distinctly. The following winter was a brutal winter, and so on and so forth. These things just stick with you for life. And I have the wonderful opportunity to have done this as a vocation, not just as an avocation. So, with that little bit about me, let's move on. If I can get the slides going forward. There we go. Greetings from the State Climate Office. If you didn't know there was one, now you do. There are state climate offices in every state, and they're independent entities, all functioning a little bit differently. As you heard, I was president years back of the national organization we formed, mostly at land-grant universities, some at state environmental agencies. It was a federal position till the early 70s, and then it was abolished with the stroke of a pen. And it's so a group in the 70s began to ramp up this ad hoc national American Association of State Climatologists, and we've stayed strong ever since, sharing information, working with each other, with regional climate centers, of which there are 6 in the National Oceanic and Atmospheric Administration's realm. Our closest one is at Cornell. And also with the national, it used to be the National Climatic Data Center. Now it's called the National Centers for Environmental Information. It is the mecca for climate data gathered around the world, for that matter, situated in Asheville, North Carolina. And yes, they got clobbered last year with the hurricane, um, but they have come back strong. I spent a year there on a sabbatical and was actually there the first night of the storm and got one of the last flights out back up to Newark. Miserable area to get hit with a storm, but a beautiful area otherwise. Perfect place to have a climate center, except when you get clobbered by a hurricane. Um, as state climatologists, it was, as Pauline said, we're here to help people solve problems. Think about it. Just about everything is connected to the weather and the climate. From your vacationing and where you decide to vacation, to the clothes you're going to wear today, to the changes we're seeing in our climate system, extremes in weather and climate, and so on and so forth. Even refrigerated produce going to market. It's important to know the temperature because they have to keep things refrigerated, which could be dependent on what the temperatures are outside of that vehicle, for instance. And as I'll mention, there's concerns with the availability of fresh water. And we in Jersey now are facing drought conditions and have had for almost the last 2 years. So we help people make decisions, whether it's from the governor's office, whether it's down to the individual citizen. We don't make the decision for you. That's the key. We don't forecast the weather. Um, I know enough meteorology to be dangerous. My assistant state climatologist, Matt Gerbush, has a master's degree in meteorology. I came from the earth science realm, doing earth system science before it was called earth system science. Um, but have had some meteorologic background as well. But we leave that to the Weather Service or to the atmospheric science program at Rutgers, for instance. Um, we can't do it by ourselves. As I mentioned, we work together regionally and nationally, and even globally for that matter. But our credo as state climatologists is we know the territory, if you will, and it's locals trusting locals. I can answer a question in this wonderful state of 21 counties. I know every corner of the state. We have weather stations in every corner of the state. I've actually, for several decades, taught a course in a geography program on the geography of New Jersey, which covers everything from the physical geography to the political geography and everything in between. So that's the key with the State Climate Office. We really know our local territory. And there's our URL if you ever want to visit our site. And that will actually link you to this page. I grabbed this the other day. You can link to our weather network, which I'll tell you about, get all kinds of information. You can look at every snow event we've had this year and go to the archives and look back 15 plus years. I write a narrative each month about the weather and climate of the previous month or season. And if you look below this, there's a link to past articles. And we just pulled from this site and put in as a link the top 10 weather and climate events I gathered and put together for the last year. In any case, enough about that. Here's where we're going to go within the next hour or so. Be happy to answer any questions you might have. Whether I can answer them or not, I'll address any questions you might have as we at the end of the presentation. So we're going to look a little bit about the drought because that's kind of the number one piece of news right now, I guess you could say. We'll look back in the generalities, New Jersey's Weather and Climate 101, look back into the past, look at the present situation outside of the drought, which we were talking about earlier, and future. We'll talk about our weather networks, our automated network and our volunteer precipitation network, and then just touch a little bit on the social science impacts side of things. How about the current drought picture? I know we're in the middle of winter and it's hard to think drought. Droughts in the winter are sneaky because you're not trying to water your lawn or wash your car. You can't see a lawn going from green to brown as you could after a dry summer month. But these figures, which you can find updated every month, we update this figure, looks back 12 months of departures from normal, of temperature and precipitation. The top left is precipitation. So every month last year, we haven't put the January numbers up yet. And anyway, I wanted to go just look at the last year. The red bars are months with below normal precipitation. The bigger the bar, the bigger the deficit in precipitation. And you can see, for instance, back here, almost 3 inches below normal last January, when we normally get about 4.5 inches of rain and melted snow. And then we annotate the figure if that particular month or season is in the top 10 for warmth, cold, wet, dry. And that goes back to 1895, 131 years. And we'll annotate that. The departures from normal are based on the 1991 to 2020 normals period. Um, as you'll see, we've gotten wetter, we've gotten warmer. The departures would even be greater if I compared them to the whole last 131 years. We only do that for the extremes. So you can see in the midst of incredibly dry, incredibly dry period, we had the seventh wettest May on record. Without that, we probably would have had a drought emergency in New Jersey with water restrictions last summer. So May was one of those fortuitous situations because you may remember the fall of 2024 was the driest fall on record. October 2024 essentially had a couple hundredths of an inch of precipitation, and it was the driest of any month on record in New Jersey going back to 1895. And September had been the third driest. So really, this drought, it began in June of 2024. We got a little reprieve, especially in North Jersey, in August of 24. And then we went down the tubes until May, a little reprieve in July. But you look at it, and it's, I can't remember, it's 16 of the last 20 months or something like that have been below normal. That's not that's not good for our water resources by any means. And thus, we are in a drought warning stage in New Jersey, according to the New Jersey Department of Environmental Protection. And on the National Drought Monitor, you'll see in a moment we have different levels of dryness and drought in the state right now. The lower right shows you temperatures. If it's red, those were warmer than normal months. Blue, cooler than normal. And you can see we had another hot summer, yet another hot summer, saved from being in the top 10 for warmth by a cool August. And then we bottomed out in December, and that kind of bookended the year with a cold January, colder than normal January, colder than normal December. But overall, the red bars prevail. Looking at precipitation departures, this is something I did a week ago. I guess it was when I was presenting to the drought task force that I sit on with folks from DEP. The brown line is how precipitation should have added up and added up and added up since September 1st of 2024, when things really got dry. The green is the cumulative precipitation that's fallen if you add it all together at Newark Liberty Airport. Um, and you can see that what we've experienced during that period up until just a couple of days ago. So let's say it's 12 for 16 months. We've had about 43 inches of precipitation. We should have had 63. So that's 68% of normal. That you can deal with for a month or two. Not so well if those months are summer months, but you can deal with it. But over this long a period of time, that's quite worrisome. So we need precipitation. This is the U.S. Drought Monitor. This is what the map will look like. It's a national map. You can zero in on your state. This is what the map will look like when it is officially released tomorrow morning, even though it dates yesterday. All the recommendations are sent in from all the states to a national author by Tuesday morning. Then several iterations of the map are done, and it's officially released on Thursday morning. So this will be the 13th map released on the 15th. And you can see the entire state is either abnormally dry or upwards of what they call severe drought. These categories are a little overstated, especially severe drought. Um, I've battled the folks at the national level, and the director of this whole program is a good close friend of mine. And we've had battles sitting at basketball games and hockey games we've gone to around the country whenever we go to a meeting. And he and I have agreed to disagree with the nomenclature that's used for these. But the fact is, this is a drought period we're in up in the northwest part of the state and just recently added to Cape May County. You only see about once every 10 to 20 years. So it's a pretty unusual event that we're seeing. The abnormal dry, every couple of years plus or so, we might see conditions get that dry at this time of the year. And it could deal with stream flow, groundwater levels, reservoir levels, soil moisture, and fire danger, agricultural impacts on native plant life, which of course could tie in with fire danger in grasslands, although if they're Phragmites, they're not native, or forests around the state. And it's based on looking at precipitation data, temperature data, evaporation data. If you know evapotranspiration, as the plants are transpiring in the summer, um, and several other indicators. So a lot goes into this map, and it was looking worse than this time last year. May and July, for 2 weeks at the end of the July, we had what we call none or D nada, we call it instead of D0, D1. But that was very short-lived, and back into it, we started ramping up as we went through late summer, fall, and now into almost midwinter. In fact, it is midwinter. Winter, climatologists, meteorologists consider winter the three coldest months of the year, and they're December, January, and February. And here we are, smack dab in the middle of January. So if you don't like winter, you could say it's half over. If you like winter, you could say, when the heck are we going to get more snow? But mind you, February and January are about equally snowy. They share the two snowiest months of the year. These are seasonal outlooks. What might lie ahead? It's very difficult to do long range outlooks a month or particularly a season or even a 2 seasons or partially ahead. Um, you can base it on things such as La Nina or El Nino in the equatorial Pacific have an influence on global weather patterns. This is a very typical La Nina weather pattern with the Ohio Valley and Great Lakes wet, the Pacific Northwest wet, the southern tier of states dry, and we're kind of stuck between the two. The one thing you tend not to get during La Nina winters are coastal storms, nor'easters. And if you remember last winter, it was a La Nina winter. We didn't have coastal storms. This winter, we had a coastal storm. It was in October. It stalled off the coast and did a lot of beach erosion down along the coast. But we haven't had a true classic nor'easter come out of the central part of the country and make a left turn and come up the coast. Doesn't mean it can't happen once during a La Nina winter. It did in 1983. Mid-February, we had one blockbuster, 20 inches of snow in 8 hours, 10 hours. But generally it tends not to be a snowy pattern. Um, but it's hard to take to the bank here in New Jersey. If you like to visit Florida during a La Nina winter. Don't go there during an El Nino winter because Florida tends to be wet during an El Nino winter. So there's some areas that you can more or less take to the bank. But here in the mid-Atlantic, I mean, we're halfway to the pole. We're still closer to the subtropics. We've got this continent to our west and we've got this ocean to our east. So we're really squeezed in with all winds and moisture and pressure patterns and jet stream variations coming in from all different directions. So it looks mild. Is this a little bit of hope to get wet as we go into spring? Perhaps. I suppose the good news is we're not locked into high probabilities of it being dry. What about our weather and climate? It's a potpourri. Um, I'd get bored if the weather and climate was the same every day. I love snow, but I wouldn't want snow every month of the year. Um, these are some of the extremes that we can experience. Gridlock, when a surprise, or not even a surprise, but a ill-timed snow event comes in, such as November 15th, 2018, in the afternoon of a Thursday. 4 or 5 inches of snow fell, not much. If it had fallen at 2 a.m. on a Sunday morning, no one would remember that storm. But I bet you there's some of you who are with us tonight who remember being stuck on the highway for quite a while. Gridlock from Camden up to Newark, up to Hackensack and such. Um, but not a memorable storm in terms of the power or the depth or anything. But it's not always the strength of the storm. Sometimes it's the timing of the storm. This one was a little bit of everything. This was Sandy down in Maniloking, where the Atlantic met the northern Barnegat Bay. Um, the most impactful event of my 35 years as state climatologist. It would rank number one in my book. This is a last time we had an EF3, was mentioned in the introduction, EF2 tornado. This is only the second EF3 tornado in New Jersey. The last one was in 1990, about 5 miles from my house here in Montgomery in Somerset County. There hadn't been one since Ida dropped one in Gloucester County on September 1st, 2021. This was the flooding that ensued in the Lost Valley region of Manville, which, as the crow flies, the Lost Valley is less than 2 miles from my house. I'm just fortunate enough to sit about 75 feet higher in elevation. But this area was just Floyd, Irene, Ida. Forest fires, pinelands in particular. We had a massive fire last April. Um, um, we dodged such a bullet. It came so close to getting in and destroying a multitude of homes. It hopped the Garden State Parkway. It's called the Jones Road Fire. It was one of my top five events. I can't remember exactly where I ranked it for 2020, 2025. And this is a cornfield in early August when you're not supposed to have a cornfield look like this. This was a drought in 2010. So anyway, we get a wide variety of weather. It's often beautiful, all the different seasons, but sometimes it can really turn on us. This slide just tells you why it's so difficult to project weather and climate, why we get so many different variations in our weather and climate. This is kind of Climate 101. And you can see all the spheres involved. The energy is provided by the sun. That sun transmits through, some is absorbed by the atmosphere. It goes down and hits our oceans and lakes. 70% of the Earth's covered by water. It can hit our lands, be they desert, be they forest. Now they're desert and forest in part because of the weather, but also the fact that they're deserts and forests feed back and influence the weather. So it's a back and forth. A volcanic eruption can change local, certainly even global climate for a couple of years after it throws its eruptive veil up into the stratosphere, well above where most weather occurs. And then look and then the cryosphere, I have to mention that. That's my domain, studying glaciers, snow, ice sheets, sea ice, and such, which is so heavily been impacted by climate change. The fastest warming parts of the Earth are at the poles, particularly up in the northern polar regions. But look at front and center of all this is you and I and our activities, our agriculture, our urbanization, our combustion of fossil fuels. Um, and so on and so forth. So we're part of these multiple national natural spheres, and we interact with all of them as they interact amongst themselves. And we have an influence on all of them, as I think we all well know. One could say we don't have an influence on volcanism, but there are actually studies that suggest that with glaciers melting on top of some volcanoes, and they're melting because the Earth is warming due to human activities, the release of that ice pressure on the mountain can result in earthquakes, and potentially volcanic eruptions. So it's not a big influence, but it still may have some direct or indirect effects. Here in Jersey, small, mighty state, but we have a wide variety of weather and climate regimes or zones. Now, we're all experiencing some level of drought now, but you have the hills of the Northwest and the valleys. Here, Bergen, step up near Mawa, Franklin Lakes area, and northern Passaic is really got two different versions. You get up to West Milford or down to Patterson and Clifton, very different. Um, it's kind of the Piedmont or the tweener zone. Sometimes that area in yellow acts more like the Northwest. Sometimes it's more like the South or coastal areas. Going to inland and a little further south, our farm areas, our truck farms down here, a milder area of the state. The Pinelands, very unique ecosystem, sandy soils that heat up quickly during the day but can cool off markedly at night. So that's a unique environment, often where drought can hit first and the impacts on potential forest fires. And then our coastal regions, which actually can slip around into Delaware Bay too. But along the coast, the ocean waters moderate winter temperatures and they moderate summer temperatures. So it's a more equitable climate along the coast. Doesn't get as warm, doesn't get as cold, and a very different growing season. This past year at our weather network stations, it was actually a station down here on Delaware Bay at Fortescue, but oftentimes Atlantic City Marina or Harvey Cedars, where we have a station. The growing season, the first freeze of the fall, didn't come this year till November 29th. The first freeze at our Walpack station up here in a valley in Northwest Jersey came on October 2nd. And in the spring, the last freeze along one of our coastal stations was the first week of March. Up in Walpack, it was the first week of May. So the growing season can be almost 4 months shorter in some of the deep valleys where the cold air drains into in the northwest part of the state, as opposed to the coastal areas where the waters are slow to warm in the spring, but generally stay above freezing and are very slow to cool in the fall. And let me also add urban effects as well, which do impact parts of Bergen and Passaic County, um, Union, Essex, Hudson as well, and down here in Camden and parts of Gloucester, urban heat islands. Those areas tend not to warm a lot above surrounding areas during the day, but they really hold the heat at night. The pavement, the rooftops, all the buildings belching heat out of air conditioners in the summer or through chimneys or out leaky windows during the winter. They tend to have elevated nighttime temperatures. Might help with your heating bill in the winter, but it's really unhealthy, very unhealthy during the summer, not only on human health, but also the health of your air conditioner. You can't catch a break. So we do have those localized heat islands as well. So it's all about altitude, latitude, surface conditions, I've mentioned several times, and those land water contrasts. All right, moving along before we run out of time. Climate change. I'll cut right to the chase. This is the consensus for the 98% of those who study climate. I mean, it's simple facts of that. Climate change, it's happening. And here in New Jersey, we're feeling its effects. Okay, it's happening. Even people who deny some of the causes of change are still have come around in recent years to at least acknowledge that things are changing. They might still disagree over why, but the general consensus of as to why is because humans are responsible for a significant portion of recent changes. Why am I so confident in saying that? We have observations, and I'll show you some observations in just a moment. We have theory, greenhouse theory, physics, basic physics that can explain why the Earth is a habitable planet. And therefore, if we alter some of the factors that make it habitable, it stands to reason it's going to change the climate. And then finally, models. Sophisticated numerical weather models. They're starting to merge some of that with AI. These use past data, initialize models. They look back into the past. They can recreate climate changes, and therefore we can then turn the dials and change carbon dioxide levels and other things. They're our crystal ball into the future. So it's not just one or two things. It's a conglomeration of pieces of evidence from modeling to theory to observations. This is hot off the presses, as it says here. I pulled this an hour ago from, I guess it was the Times this evening. I was quickly looking at it online. And this is the first group, the Copernicus group out in California, that put out an assessment of last year's climate. Um, Temperatures globally. NOAA will come out with theirs shortly. NASA will come out with theirs. There's a German group will come out. They're all based on the same data, basically the same data from oceans and from land, but they use different spatial interpolation configurations and algorithms and such. But I dare say it came in as the third warmest year on record. Last year was the 2024 was the warmest, and the second warmest was 2023. It's going to be somewhere around here. It's not going to fall down and be 4 or 5 or 6. It's not going to be the warmest. So I think it will be third from everyone out, but we're splitting hairs here. The fact is, look at what the trend has been since 1940. Up, 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 up. And we can go back further in time to 1850, the latter portion of the 19th century. We have a pretty good idea of what temperatures were. And I'll show you with New Jersey, we saw a big inflection point right about 1980, where you can see a sort of flat lined here. And then it's just taken off since then and really ramped up in the last decade. This is globally. This is globally. This is New Jersey, going back to 1895, based on several dozen stations, spatially um, averaged out over the state. So it's not just one station. It's not biased to the north. It's not biased to the south. Urban influence are removed from this, and you can see ups and downs, no question about it. But right about 1980, things started taking off. This is right about the time when climatologists recognized that a signal of human-induced climate change was emerging from a noisy natural system, and there was anthropogenic effects. There were human effects in here, but from year to year, it's noisy. The jet stream changes. You have stratospheric warming events, you have El Niños, you have La Niñas, and so on and so forth. There's always going to be that natural variability embedded with a warming trend due to human activities. And we really crossed a point of, I'd like probably say no return, if you will, around 1980. Now, people weren't running to the hills. 1988, one of my former professors at Columbia, Jim Hansen, went before Congress and said, Yellowstone is burning this summer. We've got drought. This is due to human impacts on climate. It was on the front page of the New York Times. Jim was about the first to say it. And he's still saying it now, retired from NASA and has an adjunct position at Columbia. He was one of the first to say it. And I was taking courses from him and some other noted climate scientists, Wally Broker and others, back in the late 70s, early 80s. And we knew we hadn't seen it yet. We had no discernible proof of it, but we knew it was going to come. The models were showing it. We were relying on them a lot at that time because the observations weren't quite yet showing it. Yet by 1990, I mentioned I study snow cover and look at snow cover over northern hemisphere lands from satellite data going from the late 60s onwards. We've got a record every week, and now it's every day for the last 25 years, that I maintain the database for that. And I wrote a paper in 1990 that talked about earlier spring snowmelt over northern hemisphere lands. And I had the audacity to mention that this might be due to human-induced warming that we're starting to see. You know, it, I didn't feel like a maverick at the time, but it was a small group of climatologists who were gradually understanding that we were starting to see what the theory suggested would happen. And gradually, more and more people have bought in, not everyone. They understand what's going on here. This isn't about believing anything. This is understanding. I love to say this is understanding. This is believing. We understand what's going on out there. And it's changing our world right in front of our eyes. You got to tell a story about this. People's eyes start rolling. I can hear eyes rolling when I talk sometimes with too many graphs and figures. Sometimes you want something just to tell a story. And a congressional aide once borrowed this, saw me talk. I was on a panel with her. I didn't develop this, but this is the only slide in my mind she wanted. She didn't want any of my other slides. She thought this told a story. I've been on the Hill talking about polar ice and snow and glaciers and ice sheets. And we were told not to dumb it down, don't get me wrong, but to tell stories on how this was impacting people, because that's what the legislators wanted to hear. Climate refugees on coastal areas of Alaska, because the sea ice wasn't there to buffer the waves that were coming on shore and eroding away communities. They used to have sea ice 9 months of the year, 10 months of the year. Now they only had it 5 or 6 months of the year. So examples such as that, excessive flooding from more extreme precipitation events and such, and people having to relocate because of that. Anyway, turning back to Jersey, talking to you folks who are interested in the biologic side, the botanical side of things. This is a plant hardiness zone. You've seen it, things on seed packets for years and so on and so forth. They release them periodically. This was one released just 3 years ago, using data gathered from a multitude of different weather stations, pulled together by a group out at Oregon State University. It's known as the PRISM program. And they were supported by the U.S. Department of Agriculture to update these maps. It's a lot of I can tell you when this was released, the last two versions of this, the person who developed the PRISM program was one of my closest friends. And I was with him at a meeting when not this one, the map before it was released, and the media was all over it. And he had to step away from the meeting and just handle the media attention. There's a lot of interest in this, and you folks are exemplify that, no question. We have seen the hardiness zone shift some. It's not an overnight shift, it's more a subtle shift. We're not going to have palm trees growing in Patterson naturally anytime in our lifetimes or our children's or grandchildren's lifetimes. But slowly but surely, we're seeing based on growing season lengths primarily, not as much on precipitation as on temperature, that these zones where things can grow are shifting northward or in mountainous areas vertically upwards in elevation. Growing degree days, some of you may keep track of those for your gardens and all. This just gives you an idea of the growing season length, basically. And you can see across most of the country, the growing season has gotten longer. Um, there are areas where it's not. Very interesting area here in the Midwest. The thinking is this is I was involved with work over 10 years ago on with a grad student on this. Um, this area is heavily irrigated, and the thinking is the irrigation is putting more from the Ogallala Aquifer, for instance, pumping water out of the ground, putting it on the surface. It's evaporating, forming clouds and precipitation. So this is somewhat human induced. The other thing is corn puts out a lot of moisture. And the way they farm corn these days in the Midwest, they pack it really close together. And that can really raise humidity levels around cornfields. And that may influence as well. So there's a lot of different reasons for things that are going on. But generally, growing season has lengthened across most of the country. I looked at growing degree days here through 24. I didn't update it after this past summer, but you can see the growing degree days for New Brunswick down on campus at the Rutgers Gardens since 1969. There's ups and downs, as I mentioned, natural variability, but overall, there's been a substantial change in the number of growing degree days, meaning a longer, warmer growing season. Precipitation. Let's zip through that quickly. This is 1895 to present, New Jersey precipitation. This was, um, you look at this and you can see the ups and downs of the precip. This is the drought of the mid 60s, which hit Jersey hard. The two wettest years on record, 2012 and 2018. Overall, New Jersey is getting wetter, but and this is worrisome in my book. Look at the first over half of the 20th century. You had your ups and downs, but ever since that drought and a very wet 70s, look at the year-to-year variability. It's much greater than it was during the first half of the 20th century. So you have to be ready for drought, but you also have to be ready for deluge. And we've even seen that within years, that more of our rain is falling in larger events. Even when more isn't necessarily falling averaged over time, certain parts of the globe, more of it's falling in larger events. So I like to say when it rains, it pours. And that's quite worrisome when you get into things called flash droughts, droughts that come on very quickly, and then along comes a deluge and doesn't do much help because the water runs off. It may be the ground may be hard from the drought, and the water runs right off. It's not a recipe for maintaining good water supplies and good conditions for plant growth, natural, agricultural, and such. So we are getting a little wetter. All right, theory, greenhouse effect. Um, Carbon dioxide levels in the atmosphere are increasing, methane levels in the atmosphere are increasing. What we have here is energy in from the sun has to equal energy out after it's done its work within the Earth system, in the atmosphere, in the oceans, and on land. And if they're out of kilter, we get warmer or we get colder. And what we're finding is that more energy is being held in and keeping the Earth warmer. 90% of that energy that's being held longer than before is being held by the oceans. All this warming of the atmosphere is only about 10% of the energy that's been held back and absorbed by the Earth's atmosphere and oceans. So thanks to the oceans, the atmosphere isn't warming as fast, but the oceans are warming, which is affecting ocean plant and fish life and fauna and flora. Um, and it's affecting the acidity of the ocean. You may have seen an article this week, and the oceans are becoming more acidic, which is a bad recipe for particularly calcareous shelled creatures that can't form good shells and such. But let's explain it with another cartoon. The Earth naturally has a blanket of carbon dioxide and water vapor and methane over it, just like you put a blanket on the bed at night. That blanket keeps your body heat closer to you for a period of time. Now, it doesn't hold it completely, otherwise, you self combust during the middle of the night. Eventually, that heat from your body is put out into your bedroom, just like the heat from the sun that makes it to the Earth's surface is being held by a blanket of these greenhouse gases. So it stands to reason if you're still cold, you put another blanket on the bed and it holds that body heat a little bit longer near your body. But eventually it's going to escape out to space, out into into your bedroom. And that's what humans are doing. We're putting a little thicker blanket on the bed by increasing greenhouse gases like carbon dioxide and methane. They in turn warm the atmosphere enough that it has the ability to hold more water vapor, which is the most ubiquitous greenhouse gas, but it's not the one that is directly influenced by humans as much as methane from animal husbandry and rice cultivation or carbon dioxide, which is from combustion of fossil fuels. But if you take those trace gases and they warm things, that allows more moisture to be held in the atmosphere, which increases the greenhouse further. So it's a little complicated, but just think of it as putting another blanket on the bed. So it stands to reason, physics tell you if you increase your greenhouse gases, you're going to get warmer. I mean, it's basic physics. So anyway, and then we have these models which look at all different variables and all different levels of the ocean and the atmosphere and biota and the chemistry of all of this. And they run on some of the world's fastest computers. And that's, as I said, is our crystal ball into the future. So what does that crystal ball say? Rising temperatures, steady or increasing precip, more variability, more extremes, and we're a coastal state, rising sea levels. These all prescribed for New Jersey. Rising temperatures, it's a global issue. Precip varies. The dry areas are projected to get drier. The moist areas, and we're a pretty moist, wet area, wetter, and polar regions, because they're so cold, you can't hold a lot of moisture in cold air. But as they warm up, they can hold more moisture and they'll get more proportionately wet or even white as long as temperatures stay below freezing there. Um, Increasing variability. And notice I say storms, flood, drought, and heat. And you're going to say, okay, Robinson, the only thing you missed there is cold. And you can pop some cold air in once in a while too. Just wait till this weekend and next week. But I talked about this variability. Um, if it's warm and you can't get a trigger to get the moisture out of the atmosphere in a storm with rainfall or snowfall event, that warmth is going to dry things up faster than it wasn't quite as warm in the past. Now, that's going to lead to drought. But along comes a trigger to get the moisture out of the atmosphere. Because the atmosphere is warmer, it has the potential of having more moisture. So when it rains, it pours. So you go back and forth and back and forth. Flash drought, a deluge, flash drought, a deluge. It's not as simple as that, don't get me wrong. And with that come attendant flooding, heat waves involved, and such. So it's a recipe for more extremes. And then along the coast, most of the Earth's coasts, from the melting, first of all, the heating of the waters. Remember, I said the waters, 90% of that extra heat is being held by the oceans. They thermally expand. Also, glaciers are melting, ice sheets are melting, and have the potential to raise sea level tens of feet. Thus far, we're talking a foot or two. Um, but sea level certainly is rising. The only place, ironically, it's not going to rise is near the Greenland and near the Antarctic, because as the ice sheets melt there, those ice sheets are so heavy, they push down on the lithosphere, on um, what you think are solid rocks, but aren't. And when you release that pressure, the land will rise and sea level will actually fall. Meanwhile, all that water that's been melting goes elsewhere around the world and raises water levels. If you melt all of Greenland, um, about 10 feet of sea level rise. Western Antarctic, 10 feet. East Antarctic, 50 feet were it to melt. Now, that's not going to happen again in your lifetime, your kid's lifetime, your grandkids' lifetime. Um, just a new report out of Rutgers that sea level has risen about a foot and a half in New Jersey over the last century. Um, the majority due to the warming waters off the coast, and to some melting ice, glacial ice and such, but also the land is rising, excuse me, sinking in South Jersey. It bulged up when there was ice to the north 20,000 years ago, and believe it or not, it's still subsiding. So, but that's going to be overwhelmed in projections through the remainder of this century and beyond. And we just at Rutgers, with DEP and some other universities around the state, released the latest second update of a report 2016, 2019, and we just released one at the end of 2025 on projections of sea level in New Jersey, for the rest of this century and into next century. You can Google it and find it online. It's not much different than the 2019 report. So is a group, um, some experts that really look at the sea level. I was involved in looking at the threat of severe storms, adding insult to injury as we go through the remainder of this century. Um, these are observed in projected temperatures, and you can see as we go through the remainder of the century, this green area is a projected range of warmth due to if we control our greenhouse gases, go greener. If we just let things run as usual, the projections are higher, and you can see we're over 10 degrees Fahrenheit then at the most extreme. Now, you'll also notice that up until 2050, they overlap completely. What this tells us is that the die has already been cast for where we're going to go for the next 25 years or so. No matter what we did right now, that whatever the emissions scenario, that's where we'll be. But what we do now is going to have an impact on whether we go here or here by the end of this century. And that's hard for the general public and certainly politicians, to comprehend. And I get it. That's difficult, because this isn't an overnight thing. An extreme weather event certainly can be, but not the overall pattern of change. And the better and sooner we recognize it, and we're already several decades late in getting a good start on this, the better off. Now we're talking about our kids and our grandkids who are going to be around at this time. So That's the general picture looking ahead. I just want to briefly introduce you to our Rutgers, New Jersey WeatherNet. Pauline said we have 69 weather stations. We just commissioned last month our 70th station since my bio hasn't been updated. Um, in Actually only a mile away from my place here in Franklin Township, Somerset Park, by the confluence of the Raritan and Millstone River is our 70th station. Each station has its own web page. There is one Hallworth at Veolia Water, right on the banks of the Oradell Reservoir. There's one of our stations in Ramsey, one in Lyndhurst, out in Charlottesburg, North Halden. I'm thinking the local areas in Passaic County and such. Charlotteburg is in Passaic, but it's right on the border with Morris there. Um, and every 5 minutes, we pull these stations and download via cellular modems, and they're all solar powered, a wealth of weather variables, temperature, precipitation, um, and they're all over the state. As I said, every 5 minutes. I haven't even updated my own slide here. We have 70 of them now around the state. These are the variables they measure. Not everyone measures every single variable. Your closest snow sensors, they're acoustic snow sensors. They show the depth of snow on the ground, not necessarily the snowfall. Jersey City has one at Liberty State Park and in Passaic, on the campus of Montclair State, Little Falls, part of the campus has one of those gauges. But we only have 7 of our stations that have those. Some measure wind 3 meters, 9, 10 feet off the ground. Some measure wind speed and direction 30 feet, 10 meters off the ground. That's the general standards. And they have all the other equipment closer to the ground. So invite you. As I said, we have the network itself, njweather.org, but then you can go and pick out your closest site to you, or if you want to see what's going on in Cape May, or we have a station at High Point Monument, just down the driveway from the monument itself. You can look in all directions. For the agricultural folks and botanical folks, we have some of our stations measure soil temperature and water content at 5, 10, 20, and 50 centimeters. I'm mixing my metric and my English units here below the surface. And you can see the closest to you would be Charlottesburg. Um, we don't have a wealth of them out there, but we have some. This is, if you know, Duke Farms in Hillsborough. This is the Rutgers Gardens in New Brunswick. Um, this is Rutgers Snyder Farm out in Pittstown in Hunterdon County. Just and that's up in Chester. That's our newest station in Chester Township, in collaboration with the Highlands Commission. And this would be your soil temperatures, and this is your water. We don't color code water content. It varies so much locally, as you well know, due to soil type, for instance. We also have the air temperature. We have solar radiation at almost all of our stations, incoming solar radiation, wind speed, wind direction. This we calculate evapotranspiration based on temperature and humidity. So that's a generated variable. But all of these might interest you, and you can find it in map form and tabular form on our website. Also, I don't know if any of you are CocoRa's observers, Community Collaborative Rain, Hail, and Snow Network. It's a national program of citizen scientists. It's the most active citizen science program that operates on a daily basis on Earth. Guinness Book of World Records actually a couple of years ago recognized that. And the folks that run the CocoRa's program nationally didn't learn that until about 2 months ago. Someone told them. It's run out of Colorado State. University, but we're the Jersey chapter, if you will. Matt Gerbush, my assistant, and myself co-lead it. We have about 300 active observers who purchase a $40 rain gauge, put it out in an open area. Um, they get a ruler, measure snow to the 10th of an inch snowfall, snow on the ground to a half an inch. They go online or on their computer or on their cell phone on an app about generally 7, 8 in the morning and load what happened in the last 24 hours. Goes to a national database. There's maps. I guess I didn't include any maps here. And you can see what your neighbor got. My closest, I'm a CoCoRaHS observer. My closest one's my neighbor who's about 5, 6 blocks away. Um, but you can compare across the country and even into Canada and the Bahamas have some observers. So it's a wonderful program for people of all ages involved. They go to cocorahs.org. There's all kinds of training. There's places you can sign up, There's links to where you can purchase a gauge and how to install it and how to observe and so on and so forth. So we would invite you to join. We have observers in Passaic and Bergen County. We never have enough observers because it could rain one end of the block and not at the other. It's a little bit extreme, but I'll tell you, my neighbor, who's less than a half mile from here, we hardly ever get the same precipitation total. He had an inch more last year, and we know why. It was one major storm. The same day it flooded out in Plainfield. He had an inch more than me that day, and we're a half mile apart. And for the year, we evened out everything else, and we just look back to that one day. Just finishing up quickly. Climate change impacts. It's affecting everything we see around our state these days, our health, the length of seasons for invasive species that can bring disease with it, agricultural impacts, southern pine beetle affecting our pinelands because it doesn't get cold enough in the winter to freeze out the eggs on those invasive critters. Water resources, more volatility in our water supplies, coastal impacts, species in natural areas. I don't have to tell you folks, I don't have to tell people from all these sectors that the climate's changing. I go and talk to various groups. They tell me the impacts are going on, and I maybe explain a little bit why they're being impacted. So what do we do about it? A little preachy here, forgive me. We've already talked about understanding. Thanks for tuning in tonight. Hope you understand things a little better. The better we understand what's going on, and the more we come to a consensus on that, we can spend more time on mitigative and adaptive strategies to address the issue rather than just I've spent way too much time in my career having to explain to people, what and why it's happening. Although Jersey is a very educated state, you should hear the stories I hear from other state climatologists in some parts of the country. Um, we can take mitigative activities to reduce greenhouse gases, less energy, cleaner energy. But we're not going to mitigate ourselves out of it. I've been telling my classes that for 35 years. We're going to need to be more resilient. We're going to need to adapt. The more we can mitigate, the less we have to adapt. We'll leave it at that. And then we need leadership. It needs to be on from the local level to the national level to the global level. It really takes this global village to address the problem. So forgive me, I'll get off my the pulpit here and let's just sum up. Very wordy slide. Don't like wordy slides, but boy, we got a variety of conditions in New Jersey, and oftentimes that's great, but not always. Change is going to continue in Jersey. It's going on now. It's going to continue to change and accelerate in terms of sea level rise and our warming in the future. And with that, more extremes. With that, more impacts. And I said native plants certainly remain at risk. We have to keep a watchful eye, become a COCORA's observer. I keep going after support for our weather network, which doesn't run itself. But I don't want to leave you on a real down note. We were smart enough to get ourselves into this situation, developing the combustion engine and decimating forests and deforestation. Well, I'll go on and on and on. We were smart enough to get ourselves into this mess. I'd like to think there are enough smart people out there now and in the future who are going to be able to address and wrestle with and help solve and get to the mitigative and adaptive side of things. So I don't want to leave people devoid of any hope that we're in it and there's no turning back and boy, we're really in trouble. We are in trouble. It's a crisis, but there's still some hope for the future. And with that, thanks so much. I'm going to stop sharing and start answering any questions. I appreciate it. If you have to run, I get it. But thanks for joining in for this hour.
Okay, thank you very, very much, Dave. Dr. Robinson, this was I was fascinated. I was kept writing notes. It was fascinating, and we do have some questions. We have some very general ones and some very specific ones. So this one I think is really interesting because I find it difficult myself to figure out how different government agencies work together. So somebody wants to know, how does your office work with New Jersey DEP? Or if you do work with New Jersey
Oh,
DEP, how does that work? How does it work together?
very, very closely with them. It has depended a little bit on the administration, I might add. But overall, look I've served under how many governors since 1991? I've never had political pressure put on me. I consider myself apolitical when it comes to the activities, but some administrations have paid more or less attention to climate. I sit on the drought committee. They provide substantial funding to maintain our weather network out there,
I see.
and they use that data. I work with the Forest Fire Service there. I work with the Water Resource Group. We've developed an app to help warn when excessive precipitation is falling for the dam safety group there. We have wonderful relationships with DEP more than any other state agency. I've
Mm.
worked with, you name the agency, I've worked with them, but nothing as supportive as the cooperation we've had between our office and DEP.
Thank you. A very specific question. August used to be the wettest month, according to some of the records that you showed it. Has that changed? Is it still true?
It's a back and forth depending on your 30-year mean periods or longer term means between July and August. And I know that blows people away. I get my students on that if I want to give them a trivia test. What's the wettest month of the year? Oh, it's April showers, or it's March. There's a lot of mud. That is a great way of introducing to people that rainfall is just part of the whole cycle, the hydrologic cycle, which
Mhm.
includes evaporation and evapotranspiration. So we get about 4.5 inches of rain in August and July each month. And as I said, they wrestle it out. Now, our driest month is February, and it's about 2.9 inches. Of
Mm.
course, it has a few less days, so it's cheating. But most months are between 3.5, 4.5. So we have a pretty equitable distribution of precip during the year, which is great because that means we can climb out of a drought at any time of the year.
Mm.
California, not so much. So, but in the summer, if you measure the evapotranspiration, it comes up to, say, if you had a swimming pool or a pond, you'd see about 6 to 8 inches evaporate, and only 4.5 inches is falling. So you have a
Mhm.
net deficit, even though it's the wettest month. But thank goodness it's the wettest month because that can help our crops grow and minimize the need for irrigation. But still, that's why I like to say you don't have mud pies in July. You'll see them in March or April.
Mhm.
So it's a great way of talking about the whole hydrologic cycle.
And then sometimes you get so much rain in the summer that your tomatoes split on the vine. That's always fun. But we have more questions. So somebody would like to know, Betty McDonald would like to know, I'm saying names when I know the people. Am I imagining that it has been more windy? And if so, why?
I get that. I've gotten that for the last decade, it seems.
Oh, that's interesting.
And I've had a couple students look at it. I have one right now. He's more looking at wind directions, and he's presenting a poster at the American Meteorological Society meeting in 2 weeks down in Houston. One of my senior meteorology, he's a meteorology student, but he works in our office. I had another intern, and she looked at winds at Newark Airport and Atlantic City Airport going back decades, and there's no trend. There's no trend. And unfortunately, that's about all we have is airport stations before our network came into existence 20 to 25 years ago.
Hmm.
Mind you, one station just 3, 4 weeks ago. So we don't have a long enough period of time to look for any long-term trend. But let's look, read my top 10 for the last 2 years. And one of the top 10 each of the last 2 years has been how many 40-mile-an-hour plus wind gust days. We had 99 days last year when winds gusted to 40 miles an hour or higher at least one of our 69, 70 weather network stations. Sometimes it was just High Point Monument. Sometimes it was
Yeah. Hmm.
just Harvey Cedars. But there were also a handful of days where 30 of our stations gusted to 40. So I feel I get it. I get your read on that. And unfortunately, our network, we'd have to look at just the stations that have been around 20 years. There's a dozen or so as the network has grown, but it's something to keep looking at. But right now, there's no definitive evidence that Jersey's getting windier.
I have thank you. I have two questions here that they're kind of related. They're both about green infrastructure, which is something that a lot of us are concerned with. So one person is asking, are there any data showing how green infrastructure influences climate, or if it does? So theoretically, it's improving the local water cycle because it's reducing flooding. But is there any data? And then another question, what are some high impact mitigation techniques, which is, I guess we're talking about, that we could all do?
Yeah, and let's talk about the greening of our urban areas, for instance.
Mhm.
We know there have been studies of urban areas. There have been reforestation efforts in cities, and they show that the shading of the trees, the evapotranspiration, the moisture coming
Mhm.
from those trees can cool the area. It also
Mhm.
improves air quality, I might add. But it takes a long time for trees to grow. There is an effort to plant 1,000 trees in Newark. The first few have gone into the ground. It's working with the city of Newark and some other groups there. And the Nature Conservancy of New Jersey got the major grant for this. Full disclosure, I'm a trustee of the Nature Conservancy of New Jersey. There's been some efforts in Patterson. I was up there this summer with the mayor, was joined us, and our environmental subcommittee of the board of the New Jersey chapter.
Mhm.
And there are efforts to green up the urban areas. It's going to be so much healthier, so much better for the citizens. But you can't plant little twigs like you can along a riverbank as you're trying to put more trees into a floodplain. They'll never survive in the city. So you have
Mhm.
to put in a more substantial kind of trees with a girth, and that's expensive. And you have to plant the right trees that aren't going to lift up your sidewalks and trees that don't need an abundance of moisture because of the
Mhm.
impervious surfaces that don't deliver water to them. So it's a
Mhm.
tough task, but there's no question that the evidence is out there. Louisville, Kentucky is the probably the biggest success story in the country right now. If you look that up, and their afforestation or reforestation of efforts in their urban area. So great question. Ties right in with you folks. The greener, the better.
Okay, yeah, and the benefits of individual trees improves over time, obviously, because the when they capture more and more carbon as they get older, they give off more oxygen, so more water vapor. The I had two questions that I wrote down myself as you were talking. First of all, very simple. What is the difference between snowfall and snow on the ground? It sounds to me like they should be the same thing.
A snowfall is a single event, which is measured. Basically, you're supposed to measure
Oh,
it
I get it.
at
I
its
get it.
greatest depth of fall. And we actually have
I get it.
snowboards that you measure on. Snow on the ground can be multiple events. We see snow on snow events in
Hmm.
New Jersey, better up in the northern part of the state than the southern. Um, we're not, but we have a lot of ephemeral snows in Jersey. It's come and go. Look, a couple times already this winter, it's come and gone. So that's the difference. I'm more interested. I love a snowstorm, don't get me wrong. But snow on the ground insulates the ground.
Hmm.
It doesn't freeze as deeply. It's more reflective, so it reflects away a lot of solar energy, which can cool the environment, which can lead to more snow, positive feedback. It holds water resources. That's the biggest thing about snow on the ground. More so out west, where they're in big trouble right now. Except the Cascades and the Sierras did better the last couple of weeks, but the Rockies are in a snow drought right now, and that's real worrisome. Come spring, that's the reservoir out there, not like our liquid water reservoirs.
Hmm.
So that's something to keep an eye on, folks, is just the snow drought out there in the Rockies. And if you're going out there, they're skiing, check in with folks first.
Okay, one last question, I think. How is the incineration of plastic and general plastic pollution impacting our climate?
Yeah, there's not been a lot of studies on plastic per se. You mentioned incineration, and that can loft, I don't know the concoction of chemicals that that puts in the atmosphere, and if some of them lean towards greenhouse levels. The microplastics, if they were to get in the atmosphere, could even have some impact, although they tend to be more in our water bodies
Mhm.
and our fish and humans for that matter. So I can't speak to anything directly to plastics and climate, but it's all part of the whole pollution problem, which ultimately impacts our climate.
Mhm. Okay, I think that is our questions. We have lots of people saying thank you, as do we from Bergen Passaic. Thank you very, very much. This was extremely interesting. And thank you, everybody, for attending. And we hope to
Thank you.
see you next month. Thank you very much, Dr. Robinson.
Great. My pleasure. Bye bye.
Okay. Good night, everyone.